Hello my dear friends, welcome back to your channel of learning mathematics. We have two more questions to be solved from exercise 7.1. So the first question is, let's get straight to the question. That is, the first question is question number 8. And that would be, in a right triangle ABC, right angled at C, M is the midpoint of the hypotenuse AB. So these two sides are going to be equal. C is joined to M and produced to the point D such that now DM is also equal to CM. Point D is joined to point B. Show that, okay, we have 4 conditions to be proved. So let us begin. So let me not write what is given. Okay, chalo, let me just write what is given. That is given right triangle ABC, right angled at C. So this is our 90 degree angle C, ACB. Then of course we have DM. C is joined to M, and M is the midpoint of hypotenuse AB. M is midpoint of AB. So in that case, if M is the midpoint of AB, in that case AM is equal to BM. And I'll write directly, DM is also equal to CM. So these are the conditions that are given to us. So definitely we are going to be requiring this. Okay, let's just go for the proof. So the first one, that is to prove that triangle AMC, this triangle, is equal to BMD. So that's not going to be a very difficult thing to prove. Everything is there. So alright, let's say number 1. Okay, in triangle AMC and triangle BMD, already given AM is equal to BM, AM is equal to BM. So if we just draw the triangles like this, so that we can match. So AM is equal to BM. Also DM is equal to CM. So both these conditions actually are given to us. So sorry, AM, let's write CM because we are going from AM to BMD, this triangle, from this to this, na? So CM, so that there is no confusion, equal to DM. So CM is equal to DM. And triangle, definitely these two angles are going to be equal, vertically opposite angles. Angle AMD is equal to angle AMC, sorry, AMC is equal to angle BMD, vertically opposite angles. So therefore these two sides, these sides included angle equal. So definitely what? By side angle side congruency criteria, triangle AMC is congruent to triangle BMD. Done. So the first one is done. So with that, what happens is, we might need it. So AC is equal to BD. That will be CPCT, congruent parts of congruent triangles. We might just need that. And the remaining angles also become equal. That is angle ACM. This angle ACM is equal to angle BDM. Angle BDM. That is also corresponding parts of congruent triangles. Alright. Okay. Done. You can pause the video there and note down. Alright. So then second what we have to prove is angle DBC is a right angle. So that means I have to prove that angle DBC, this is also a right angle. All right. So now just now what have we proved here is angle ACM is equal to BDM. That is ACM, this angle, is equal to BDM, this angle. Now doesn't it look familiar, this angle and this angle? Does it look familiar? Definitely, I guess, because if you have parallel lines and then there is a transversal that cuts, and if these two angles are equal, that can happen only when they are alternate angles, and alternate angles can occur only when the two lines are parallel, isn't it? So what we have here is, but what am I trying to prove? That this is 90 degree. So for that, if you can somehow prove that these two lines are parallel and this is already 90, this one, then we know that sum of angles on the same side of transversal, between parallel lines is how much? 180. So since this is already 90, this angle, we might just be able to prove that this is also 90. Let's see. But angle ACM and angle let's first write down. Angle ACM is equal to angle BDM. That is actually proved. So, but angle ACM and angle BDM, actually are alternate interior, I'm just writing in short, alternate interior angles. So what it does is, I'll just draw the figure once again. So what it will do is, as it is mentioned, these two angles are equal, no? That is AC, okay, this one was M, so we have shortened it. ACM is equal to BDM. So what will happen is AC becomes parallel to BD. AC becomes parallel to BD. No question about that. Then in that case, what will happen is, again I'll draw that figure once again. So in that angle, since those two lines are parallel, that is ACBD, so these two lines are parallel. So in that case, then angle CBD plus angle ACB or BCA. Okay, since again, sorry, we have to use DBC, so I'll just use DBC so that it doesn't create any confusion, plus angle ACB is equal to 180 degree. Now what will be the reason for that? As I just mentioned, we will just write down the reason also, that is sum of interior angles on the same side of transversal between parallel lines is how much? 180 degree. So, but actually what is given? But angle ACB is 90 degree. This is actually given because it's given that it is right angled at C. So angle DBC plus 90 degree equal to 180 degree. Let's say we haven't put any equation, so let's say this is equation 1. So that is, let's say from 1. So angle DBC will be equal to 180 degree minus 90 degree. That will be how much? 90 degrees. So this is a right angled triangle. So that's the second part that we have to prove, that angle DBC is a right angle. So that is also done. Next, what we have to do is, number 3, we have to prove that triangle DBC is congruent to triangle ACB. So that is, I've just cut out. That is, next we have to prove that triangle DBC, this triangle. So let me just write down. Let me just draw that triangle so that there is no confusion. Nah? So triangle DBC, we've just proved that this is 90, okay, is congruent to triangle ACB. ACB, this is also 90. All right, okay, so let's go for the proof. So we can prove directly. In triangle DBC and triangle ACB, what happens is BD is equal to AC. BD is equal to AC. That was actually proved in the beginning. Let's make this as 1. So proved by equation 1. So that in that case, let this be equation 2. So we'll change that to 2. Okay. So BD is equal to AC, already proved. Angle DBC is equal to angle ACB, that's 90 degree each. And you will see that the side BC is common for both the triangles. BC is equal to BC, that's common side. So by side angle side, isn't it? Side angle side, sides angle included. So side angle side congruency criteria, triangle DBC is congruent to triangle ACB. So that's also proved. So the last that we have to prove is, so the last part that we have to prove is the fourth one. That is, we have to prove that CM is equal to half of AB. That is, CM is equal to half of AB. Now you see what happens. Since we have proved that these two triangles are congruent, what happens is CD is also equal to AB. Since triangle DBC is congruent to triangle ACB, what will happen is CD is equal to AB, corresponding parts of congruent triangles. So if we just divide half by on both sides, half of CD is equal to half of AB. All right. Now what is half of CD? Half of CD is either, half of CD, because in the question it's clearly given that DM is equal to CM. DM is equal to CM. That means M is the midpoint, isn't it? So half of CD is either CM or either DM, any one. So since in the question we mentioned CM, so we will use CM. So half of CD is nothing but CM. CM is equal to what? Half of AB. So that's proved. So that's how it is done. All right, so I guess that was not that difficult. All right, okay, let's go to another question that is actually not in the NCERT textbook. This is only in the Nagaland Board of School Education edition, but this is a very good question. Extra question, I would rather say, but a very common question actually, this one. What it says is, in a right angled triangle, let's say PQR. So I'll just draw with my free hand. Actually, this is a common question which is so much similar to prove that, the midpoint of the hypotenuse is equidistant from its vertices. There is a common question based on that. So this is just another version of that question. So PQR right angled at Q, X is the midpoint. So then PX is equal to RX. Prove that PX is equal to RX equal to QX. So of course we will have to join QX. So we have to prove that these three sides are equal. Alright, so given a right angled triangle PQR, right angled at Q, X is midpoint of PR, so definitely PX is equal to XR. To prove PX is equal to XR, of course already given, is equal to QX. Now here what we will do is we will do a small construction. Actually this question can be solved in different ways. Okay, one of the most simplest ways is using coordinate system. And in just 3-4 lines we can easily get the proof. We can also use proof using the midpoint theorem. That way also it can be done, but the condition is that since this question is given in exercise 7.1, that is based on congruency of triangles, I will try to stick to congruency of triangles only. I'll not try to go beyond that topic. But as I said, it can be easily proved using, you can check out in the internet and all. It can be easily proved using coordinate system or even midpoint theorem also. But as I said, we'll just stick to congruency because this question is given on exercise 7.1 based on congruency. So we'll try to prove using congruency only, no other concept. So what I'll do is I will produce, so since we have to use congruency, it might go a little bit lengthy. Okay, produce QX to S so that QX is equal to XS. So what I'll do is QX I'll produce to S like this, something like this. It may not be exact, my figures diagram. So this is also construction only, so just dotted lines. Okay, S. All right, so I've done that construction. So it's somewhat similar question to last question. Proof. I'm trying to prove that these three sides are similar. Now you see how I prove it using congruency. So just like last one, I'll try to prove that these two triangles are congruent first. So in triangle PXQ and triangle RXS, PX is equal to XR. This is already given. QX is equal to XS. This is by construction that we are doing. No, we've just done a construction. And of course, angle PXQ is equal to angle RXS, vertically opposite angles. So triangle PXQ becomes congruent to triangle RXS, that is by side angle side congruency criteria. I will not be using any other conditions. Okay, side angle side congruency criteria. So just like the last one, if I just draw the figure congruent triangles, the two congruent triangles, it's always nice to have this rough figure, especially when you study, you know. So X is the common point, so PX is equal to XR, QX is equal to XS. So PX, RX, QX, XS, these two angles are equal. So once they are congruent, what happens is SR is equal to PQ and angle RSX is equal to, almost similar to that last question. Okay, PQX corresponding parts of congruent triangles. Let's name this as condition 1. All right. Okay. But now you see, but again, RSX is equal to PQX. So again, like that last one, let me not repeat that. Chalo, repeat the parallel lines, transversal, this angle is equal to this. When can this happen? Alternate interior angles are equal. This can happen only when these two lines are parallel. But angle RSX is and angle PQX actually are what? Are alternate interior angles. So again, PQ becomes parallel to SR. PQ is parallel to SR. Then only the alternate interior angles will be equal. So using that same reason again, so angle PQR plus angle SRQ would be actually again equal to 180 degree. That means angle PQR plus angle, this angle, that is SRQ again will be 180. The reason again, that same reason that we wrote for that last question. What was the reason that we wrote? Last question again, that is sum of interior angles on the same side of transversal of parallel lines is 180 degree. Okay, but in the question one thing is given, that is angle Q, that is PQR. This is 90 degree already given, right? Angle at Q. So 90 degree plus angle SRQ equal to 180 degree. So angle SRQ equal to 180 minus 90. Okay, that is 90 degree. So now even this angle is also 90 degree. Okay, what are we doing here? Where are we going? Now you see what happens. Actually the same proof. Thus in triangle PQR and triangle SRQ, that is, I'll draw the triangle once again, that is triangle PQR and SRQ. 90 already proved, right? Angle PQR is equal to angle SRQ, 90 degree each. PQ equal to SR. PQ is actually equal to SR, that is from 1, that is CPCT. PQ equal to SR. And again QR is equal to QR common side. So triangle PQR is congruent to triangle SRQ. Again side angle side. Congruency criteria. So it's like a repeat of that question. So what will happen is PR would be equal to SQ. So if I again divide half. So what is half of PR? Half of PR. X is the midpoint already given. So we need PX or XR, anyone. So half of, let's say, PX. And what is half of SQ? Half of SQ? Half of SQ is actually what? Again, because QX is equal to XS. That's how we took the construction. So even X is the midpoint of SQ. So half of SQ can also be written as QX. So PX is equal to QX and PX is also equal to XR. Isn't it? That's so. That's it. Proved. Alright, so this is a very good question. Another version of this question is, as I said, prove that the midpoint of the hypotenuse is equidistant from its vertices. So that's another way. All right, so that's how this question will be done using only congruency. I haven't used any other property here. All right, so fine then. I'll see you in the next exercise with the new concept, another new topic. All right, so study well, take care, see you soon.